welcome to this session. It's my second session here at Techorama, and I'm really excited about this session because it is about a topic that is very relevant, especially this week, because we are here in Europe, and this week is a special day when it comes to data security, or a special week when it comes to data security, because this week the GDPR is put into place. And therefore, Europe is currently very sensitive when it comes to data protection and data security. And in the next 60 minutes or so, we are going to talk about how we can improve security for our .NET applications, well, in general, our applications that run in the cloud, specifically in Azure. I'm going to show you what Azure services are there in order for you to be used to store secrets, encryption keys, certificates, and so on. And I'm going to show you how Azure makes it rather simple and therefore secure and robust to access these secrets via APIs and things like that. Let me quickly introduce myself before we go into the technical details. My name is Rainer Stropek. I am from Austria. I have a small company there, and what we do is we are building software as a service solutions on the Azure stack. Not on the Azure stack, on the Azure technology stack, on the Azure cloud. We have been doing that for 10 years now. So we started it when Azure was born. Our whole company was born in the cloud and born in Azure, and therefore this topic is very near to my heart. All the things that I'm going to show you over the next 60 minutes, we are already using them for quite a while, and if you have any questions afterwards, feel free to come to me and I can tell you more details about how we use them. I will invest, let's say 10 minutes or so, maybe 15 minutes in a few slides, not so much, not so many, but afterwards we are going to go into demos. 90% of this talk will be about demos, and you will see some source code, not so much .NET code, a little bit of .NET code, but a lot of Azure CLI code, automation code, and things like that. I've put together everything and put it on GitHub, so you can follow this bit.ly link to get the sources. So you do not have to write things down and things like that. You can just download the sources afterwards. Additionally, I'm recording this session. So if the technology is working well, I will put the session on YouTube after my session, when I come home in the next few days. So feel free to connect with me via Facebook, Twitter, LinkedIn, whatever, and you will see me posting the YouTube videos there. So what is the problem? I always like starting talks by discussing the reason why we are talking about this problem. And the problem is that what I typically see when working with a lot of customers in workshops, in consulting projects and things like that, that it is still a problem to store secrets in applications. We have this secret that we need to access a database or a foreign API and so on, and in many cases I still see developers putting these secrets into code or into configuration files in plain text. And of course that's not good, because people can eavesdrop on these secrets. You can easily forget to wipe out these secrets if you copy the code to a colleague or send it via email, of course in an unencrypted way. It can happen that you consciously or unconsciously check in the source code or the configuration file in your source control system. That's bad if the source control system is private for your enterprise. That's even worse if your source control system happens to be GitHub, because then everybody has access to these secret keys, and if your resources are in Azure, publicly available, they can use these keys to access your valuable data or to do some Bitcoin mining on your valuable Azure virtual machines. Of course, we don't want that. We want to protect these keys from hackers and from malicious insiders. And even when we carefully care for not publishing the secrets that we have in code or in configuration files, but we still store the secrets on our servers, in our configuration files and things like that, there is still a risk. Because if, for some reason, somebody gets his hands on these secrets, they can store these secrets and use it for a long time. And therefore, it's important to rotate these secrets regularly. If you put your secrets, just plain text, into your code, it is very hard in large-scale systems to do key rotation. Therefore, we need a solution for that, and we need to make it very easy. We need to make sure that it's very easy to rotate secrets and to have practices for that in place. Everything is simple if you have just a single application. The challenges start if you want to scale that. If you're working in an enterprise that has dozens, maybe hundreds of microservices, and you have your secrets, your connection strings, your API keys, your encryption keys, your certificates, sitting in every application somewhere else in some config files, inside the code, and so on, it's really hard to manage these things in scale. Keeping them secure is a problem, I already discussed that, but also keeping it available. Of course, you can make security harder and harder, but if you put measurements in place that the developers don't like to use because they are so complex to use, nobody will use it, and they will again store their secrets and keys in configuration files. And last but not least, speaking of GDPR, we want to audit these things. We want to know who accessed which secret, which key, which certificate, when. We need to export these things, and we need to be able to have some governance and auditing on these log files. Enter Key Vault. Key Vault is a service in Azure that you can use to store your secrets, keys, and encryption keys and certificates in. And these key vaults allow you to create vaults in Azure. It's just like your personal password manager, like KeyPass or whatever you use. But Key Vault is not for you as a human being, it's for applications. So it is good in APIs. It has a REST API, it has a .NET API, and there are many other APIs out there that you can use to access your secrets. It is a centralized storage, and it has a bunch of very interesting properties. It has secure containers, which can be software-based and hardware-based for your encryption keys, for instance. The key vaults are protected by Azure Active Directory, so therefore your developers can use their existing Azure Active Directory or Microsoft accounts when they want to get secrets out of Azure Key Vault. And last but not least, and that's the important one that we are going to take a closer look in this session, Azure Key Vault is tightly integrated into a lot of Azure services. You can get the keys from Key Vault and do immediate encryption in storage or databases and things like that. We're not going to take a look at that one, but we will see how Azure Key Vault is nicely integrated with a feature which is called Managed Service Identity, and this will be the core of the rest of the talk. However, one problem remains. If we store all our secrets in Key Vaults, where do we store the secret which is necessary to access Key Vault? If we put the secret that we need, for instance, a client secret, that we need to get a token, an access token to Key Vault in our configuration files, it's even worse than before, because if a malicious attacker gets the secret that opens the door to Key Vault, he has access to all our credentials, and this is definitely not something that we want. So, we have a bootstrapping problem here. We want to store everything in Key Vault, but we need a secret to access Key Vault. We cannot store this Key Vault. I mean, you get the point. It's a classical chicken-egg problem. And therefore, Microsoft invented a solution. And I think it's a solution that everybody in Azure should immediately start to use. If you do not use what I'm going to show you in the next 45 minutes or so, start using it immediately, because it will make your services more secure. This service is called Managed Service Identity. And one good news first, it's free. It's free, it's included in Azure Active Directory, and it's included in the free version of Azure Active Directory. If you hesitate using Key Vault is very cheap. It's very cost efficient. You don't have to pay hundreds of thousands of euros to store your secrets in Key Vaults. We are talking about, I don't know, some euro cents per 10,000 accesses to secrets in Key Vault. So the overall costs of the things that I'm going to show you here, it's very low, and typically that's not a showstopper. So what does managed service identity do? It simplifies the handling of secrets for various Azure services, including Key Vault, drastically. It creates the secret that is necessary to access Key Vault for you. It manages these secrets and it rotates these secrets. So, to make a long story short, you just say enable managed service identity and you can forget about how to access Key Vault. Azure will care for everything automatically. And I will show you how to enable the access to managed service identity using different versions like the portal and the Azure CLI and so on. You do not need to store any secrets in code or configuration, neither for debugging purposes, nor for testing purposes, nor for production purposes in Azure. This is fully managed by managed service identity. It supports running in Azure, of course, but a good solution has to work during development too. So the problem is, where do I store my developer identity so that my .NET application, .NET Core 2.1 for instance, knows who I, as the developer, who I am. And therefore, managed service identity has an integration with Visual Studio, with Azure CLI, and with domain-joined Azure Active Directory laptop. So if your developer laptop is domain-joined to an Active Directory domain which is synced with Azure Active Directory, you can use your single sign-on credentials as a developer for accessing indirectly Key Vault. If you don't have that, you just log into Visual Studio with your Microsoft account, for instance, and managed service identity during debugging will fetch the credentials from there. And if it happens that you do not use Visual Studio, but you maybe develop in Visual Studio Code and maybe on a platform that is not Windows, then it fetches the credentials from the Azure CLI, and I will show you that in a second how that's. Managed service identity is integrated with a lot of existing Azure services, but I'm going to focus today on the integration in Key Vault, because we only have 60 minutes, so I had to focus, and I decided to focus on the combination of managed service identity and Key Vault. But this is not the only thing. Okay, so you can use managed service identity to get credentials to access a SQL Azure database and things like that. Take a look at the documentation. I'm sure you will find the chapters there. And I even added a link here to the slides. And from now on, I promised you that most of the session will be live demos. From now on, we will switch to Visual Studio Code, and we will spend the remaining 40 minutes playing with managed service identity and Key Vault live in Azure. So, I've prepared an environment here. Let me zoom in a little bit. And as always, I'm going to tell you a little bit about this demo environment, because people always tell me, hey, Rainer, tell us about the tools that you're using here, and we want to see how you achieve the demos. First, you see this is Visual Studio Code, but I have a plugin installed which is very relevant for this demo. If I look for it here, you will see it here, the Azure CLI tools. You can install the Azure CLI tools, and then it's very easy to automate stuff in Azure because you get IntelliSense for your Azure CLI scripts and so on. The only thing that you have to do, and you see that up here, is you have to create a file with the extension .azcli, and if you do that, the plugin jumps in and it helps you creating Azure CLI scripts. These CLI scripts are platform independent. You can run them on Windows, you can run them on Linux, you can run them on Mac OS. And I decided to go for the CLI for my demos because it's platform independent. For executing my CLI, I'm using the embedded terminal in Visual Studio Code, and maybe you recognize the prompt here. It's not PowerShell, and it's not the Windows CMD, it's the bash. So I configured my Visual Studio Code to use the native bash shell of Windows 10, and so essentially we are working on Windows, but we are executing the Azure CLI inside the bash environment sitting on top of Windows. This is my environment for this demo. The first thing that you have to do if you want to automate stuff, and to be honest, the portal is nice. I'm going to show you some things in the portal, but in the real world, we rarely use the portal. We rarely use the Azure portal, just maybe for quick demos or prototypes or development. That's fine because you want to maybe explore things and visually see the different options. But when it comes to real-world programming, automation is key. So we want to automate everything, and therefore, in reality, whenever we build stuff for production, we always write either PowerShell scripts or Bash scripts with the CLI and automate things in a scripted way. And therefore, I decided to do everything in this demo in a scripted way and only switch from time to time to Portal just to show you that it's also there. But I encourage you to also maybe try to come into this automation mindset and do a lot of automation here. So if I want to connect my Azure CLI environment with my Azure account, I can do an AZ login. I did that already. If I run AZ login, I get a small code and I go to a website, enter the code there, enter my Microsoft account. Maybe I have to do some multi-factor authentication with my phone. I prepared that because I do not want you to have to wait for a minute or two until the sign-in was successful. If you have multiple subscriptions, never forget to set and select the correct subscription. If you don't do that, you might end up creating resources in the wrong subscription, and that is not always fine. And if you want to work with Key Vault, you see it here, you have to register a provider to your Azure CLI in order to be able to have the Key Vault stuff available. Now comes the first very important thing, which is relevant, which will be relevant for a later demo. We have, I zoom in a little bit so everybody can recognize it. We have a special command here in the Azure CLI, and that is AZ account get access token. And afterwards, I'm telling the AZ account get access token the name, in that case, the URI, the name of the service for which I want to have an access token. And this line is especially important because it gives me a token, an OAuth token, a JAWS token, a JSON web token that I can use to access Key Vault in my name. So as a developer, I can run this guy here. Let me quickly execute that. Oops, that doesn't look very nice. So let's pipe that in. We'll see that if we zoom in a little bit. The result of this statement will be, as you can see here, an access token. And this access token is connected to my Azure CLI identity. So I can take this access token, and because I specified that I want to use it with Azure Key Vault, this is an access token with audience Key Vault, so I can present it to Key Vault and say, I want to access a secret, and then Key Vault knows who I am without me having to sign in manually. The connection of my manual sign-in with my Microsoft account and the token was done by the Azure CLI. This is exactly that statement. So let's try something. Let's take this token, this one, copy it, and go to Jot.io, for instance. Jot.io, for those of you who are not that familiar with OAuth and OpenID and so on, it's a so-called, oh my God, it's a so-called token debugger. And I messed something up. Maybe I copied too much or too less. I'm not sure. Let's copy it again. Remove it. Okay, let's reload this website and copy it in. Come on. Okay, now it worked. What you see here is the decoded value of the token, and you see that this token has been created by Azure, by the Azure CLI, and it has the audience Key Vault. So this token can be used to access Key Vault. And how does Key Vault know who I am? Well, it's here. I see the app ID, I see my personal data and things like that. And this token is now valid for Key Vault access. Why is that so important? Later on, when I will debug my .NET code, the .NET code will have to access my secret in Key Vault. Well, how? It doesn't have any secret. And guess what? The .NET API of Managed Service Identity will run in the background the Azure CLI, ask the Azure CLI for an access token, and use this access token to access Key Vault in my name without having to present a browser window for me where I have to log in interactively. Get the idea? And the same concept is true for Visual Studio. If we quickly start Visual Studio, let's go here and open that guy in Explorer and open the Visual Studio tools here. Just like the Azure CLI can create tokens in my name, Visual Studio can do exactly the same. It can do that if I go to Options and up here select Azure Account Selection, and here I can select between the different accounts. In my case, I have 2 accounts here registered in Visual Studio. Here I can select the account, and then if I run the application in Visual Studio, the API will understand that it has to talk to Visual Studio. Visual Studio takes this account, gets the access token, and then my application will use this access token to access my secrets in Key Vault. Voila, my application for debugging purposes does no longer need any credentials to access Key Vault. Everything is handled by the Azure CLI or by Visual Studio. So, this is this guy here, and in a few minutes we are going to use this token and really access Key Vault, but by now we don't have a Key Vault token. So I have some naming constants, I will run them. Yes, now it worked. And now we will create some resources. The first one is very simple. The first one just creates a resource group. This resource group, for those of you who have not that much experience in Azure, a resource group is a way of grouping your resources to topics. For instance, it could be an application, it could be a stage, development, test, production, whatever you use them for. It's just a structuring of your resources. If we go into the portal and if we refresh the view, we will see an empty resource group. Everything's fine so far. That's not very interesting. Next, I would like to start with a demo using Azure App Services. You maybe are familiar with app services. Maybe you know it under the name web apps or serverless functions, Azure Function App. The underpinnings of all these things is app services. And if we want to work with app services, we have to create an app service plan first. Let's launch this thing here. It just creates an app service plan if it doesn't already exist. And we are creating a new one here. And I have a very important piece of information for you here. I highlighted it here. MSI's managed service identities are currently only supported in the Windows version of App Service. App Service, web apps for containers, for instance, and App Service for Linux do currently not support managed service identity, unfortunately. I hope it will come soon, but currently it is like it is not available. It only works for the Windows version. Let's refresh it, and we see our app service plan. The app service plan do not have any idea of managed service identity or Key Vault at all. The important next step, and let me quickly run this guy, and while this is running, I will zoom in a little bit. The important step is the second one. You see it here. The second step assigns an identity to my web app. So for each web app, I can ask Azure to create a managed service identity, an identity, technically speaking, a service principal that has the same name as the app. Okay? So in that case, it creates a, let's make a simplified mental model. It creates a user with the name of the application and auto-generates the necessary secrets. We never see these secrets. These secrets are fully managed by Azure and they are rotated by Azure on a regular basis. We do not have to care about them. Will we see them? Well, yes, to a certain degree. I will show you in a few seconds, but you shouldn't care about them. Let Azure manage these secrets. And the only thing that you need is this line, Azure Web App Identity Assign. So, if we take a look at that in the Azure portal and I go in here, We can also see how it would have been done interactively. It is here. See it? So if you are in the Azure portal and you want to do the things that I do in Azure CLI interactively, you can do that here. Just click on Managed Service Identity. There is a button which says Enable, and you are done. This also works for Azure Functions. So if you want to live in the serverless world, the beautiful new serverless world of Azure function apps, then this button is also here for you, and you can use it. It's supported for Azure Functions, for serverless functions. So if I click on it, I can turn it on. I don't need to turn it on now because it was already turned on using my Azure CLI script. So now we can take a look at this service principle. The next statement I'm going to run is this one here. Azure Active Directory Service Principle List Display name app. This is the display name of my application. This is the name of my web app that I just created. And with that, we will hopefully see the service principle that has been created by Azure automatically and has been assigned to my web app in the background. So let's run this guy. Let me quickly move that one away and go here and run it. Yeah, and here it is. If I zoom in a little bit, I will not show you all the JSON, but the important thing is here, display name, you see it? It's the MSI demo app live. This is exactly the app that I created now, and it was managed by Azure automatically. Again, I repeat myself consciously. We do not care about the secret at all. We do not care if this is based on a long client secret or a certificate or whatever. It's a managed service identity, not something that we use manually. Of course we could, because it's just another object in the database. Now, in order to automate the next things, and I invite you to just copy from my code here, in order to automate the rest of the things, we are going to need the object ID. Let me zoom in here. The object ID of our service principal inside Azure Active Directory. So this object ID we will need later on in order to access the service principal, to give it certain access rights and so on. Because up to now, we do not have a key vault yet. We do not have permissions to access the key vault. We just created an identity. So let's store this object ID in a variable, and I call it OID, and we will come back to this OID in a second. The next statements are connected, but something new. Let me run them, and while they are running, we will zoom in and take a look what this does. Here you see the important two lines. Key vault create and key vault secret set. The key vault create now creates a new key vault. You can create as many key vaults as you want. You should at least create 2 or 3 or whatever key vaults, 1 for each stage. So have a key vault for development, have a key vault for testing, have a key vault for production. Do not mix test, dev, and prod secrets in a single key vault. That is not how things should work. So you create your key vaults, and next you can create inside the key vaults your secrets. In my case, I'm just creating a secret password in Key Vault, and you see my secret password. We will recognize it later on. It's this one. It's just a placeholder. You can store any kind of secrets inside of these key vaults, including HSM managed encryption keys and certificates and things like that. Please check the documentation of Key Vaults to learn about all the different possibilities that you have with Key Vault. I only have 60 minutes. I have to focus on some things, and I will not go into the very details of Key Vault here. But the point is, we should now, at the end, have a Key Vault. Let's see. If we refresh it, Internet was so good the whole day. Please do not stop now. Let's refresh the browser. It still seems, here it is. Okay, just a short hiccup, whatever. keeping fingers crossed. Here we are. This is our key vault, and if we take a look at the secrets, for this demo I'm going to use secrets. This is our magic API key that we just created, and if we take a look at the API key, we will see that it has versions. And that's another very nice feature of Key Vault. You cannot only store the current value of a secret, but you have also the history, and you can create a new version. You can even create a new version now that will be put into production in a few days. So key rotation is made very, very simple as possible with Key Vault. As I said, I will not go into the details. The things that I would like to talk about are the access policies that we see here. Currently, we have a single access policy in our Key Vault. Only one person is allowed to access the secrets inside of the Key Vaults, and that's Rainer. By the way, that's me. So, by the way, that's not even necessary. You can create Key Vaults that have no access policies at all. For instance, if you deploy your Key Vaults using Azure Automation or any kind of automation framework, it's not necessary that any person has access to these keys. It's fully managed by your scripts. But in my case, I have access because I created it in Azure CLI under my account. I have access to these keys. I am the administrator of this Key Vault, but nobody else, including our managed service identity. So our web app can currently not access our keys. If I do some debugging using my personal account, debugging will already work because it will use the Azure CLI to get an access token connected with my identity, and if I present this access token to Key Vault, Key Vault will say, okay, this is Rainer, here I have an access policy which says Rainer is allowed, okay, I allow debugging, but if I publish this application to my web app that I created a minute ago, it will not work, because my web app's managed service account, service principal, has no access to Key Vault. We have to fix that. This is how we fix it. Let me run it to see the details. AZ Key Vault set policy, that defines an access policy, and we are creating an access policy for the object ID. Can you remember what this OID was? It was the object ID of the service principal that was created because we assigned a managed service identity with our web app. So we are allowing our managed service identity access to our keys, in this case secrets in Key Vault. And you will see that my system is pretty locked down because I limit the access for my managed service identity to get. So the only thing that my application will be able to do is it can get the secrets from this Key Vault. It cannot manage them, it cannot upload them, it cannot delete them, it can just get them. So let's check that in the portal. If I close that guy again and enter here in the access policies, not yet. Let's reopen it. We will see, this is exactly what I wanted to show you, we will see my account, we had that before, and now we have an application which is MSI Demo App Live, and this application now has read access to my keys. If we take a look at the details of this access policy, you will see that it has no key permissions, it has no certificate permissions, and it only has get permissions on the secrets. This is exactly what we wanted to do. So I, as a developer, can do everything with this Key Vault because it's a developer Key Vault, development Key Vault, and my app can only read the credentials from here. Of course, we can do that in the CLI too. We have a statement which is called Azure AZ Key Vault Secret Show, and if I run it, I will see the secret. Where is my secret? Here is my magic password. So I can do it in the Azure CLI too, if I want. So if I want to do some automation stuff, I can always access the Key Vault secrets via the CLI too. Okay, very good. Now we have 20 minutes left approximately, and we can switch gears a little bit. I have some lines of Azure CLI code here, which creates a virtual machine, in this case a Linux virtual machine, and I will run this script in the background. It will take approximately, I don't know, 5 minutes or so, and in the meantime we are going to do some .NET related stuff, and we will get back to this virtual machine in a minute. I just don't want to sit here and wait for it. I want to fill the time. So let's go into Visual Studio and take a look how we can make use of the managed service identity from within .NET code. What you see here is a .NET Core 2.1 preview web application. It's a very simple web application. It's a web service. So what you see here, we have an HTTP GET, nothing special. The important aspects here is first the so-called Azure Service Token Provider. The Azure Service Token Provider is the guy that will do the heavy lifting when it comes to accessing our managed service identity. So when we new up the Azure Service Token Provider, it's his job to either go to Visual Studio or the Azure CLI or my domain joined laptop to get an access token for Key Vault. Or when this guy is running in Azure, it has to know how to find out the managed service identity, the service principal that is linked with my web app, and it has to use this service identity to access Key Vault in the cloud. So this constructor that you see here will care for everything. It's just, I always call these things Harry Potter programming, a little fairy dust, and everything just works. This is exactly what Azure Service Token Provider does. By the way, it will automatically, when debugging locally, it will automatically try all the strategies that I told you before. So it will at first try to reach Visual Studio. Hey, Visual Studio, is there a Visual Studio installed on this machine that has an Azure account associated with it, where I can use this Visual Studio Azure account to get a token? If it doesn't work, it will try the Azure CLI. Is there an Azure CLI that is associated to an account? And if it doesn't find that, it will try the Windows user, the logged in user, and hope that the workstation is domain joined to an Azure Active Directory. And it will only fail if all three versions will turn out to not work. But we can also do something else. We can pass in, and I have done that here. If you want to try it on your laptops at home, feel free to do so. You can also provide a connection string to this Azure Service Token Provider and force it to use a specific way of getting the access token during development. Next, we want to use a Key Vault client. This is the API that you use to access Key Vault, for instance, to get a secret. This is the secret that we want to have. And this Key Vault client needs an authentication service, an authentication callback. And guess what? This authentication callback uses the Azure Service Token Provider that we created before. So Key Vault is going to the Azure Service Token Provider, and the Azure Service Token Provider will then go to Visual Studio, Azure CLI, or my domain joined machine to get the access token, and this access token will be given to the Key Vault client, and then everything works fine. And now we see the whole picture. During debugging, no secrets, it will use my personal identity, which is protected by multi-factor authentication using a fingerprint on my phone. If it runs in the cloud, I do not care about the service principals at all. It's managed by Microsoft Azure, and the keys are automatically rolled over as we expect them to be. So, let's prove that this really works. I will run this guy locally on my machine. And if everything works, we should see in a second. Come on, it's loading some DLL, debugging, symbol information, whatever. Here we are. What I print out in this demo is, on the one hand side, our super secret password. It's there. And I also print out the access token, because you can really take this access token out of the service token provider. So what we can do is we can take this token here, let's copy it, and let's run jot.io again. And come on. If we paste it in, we are going to see that this is again our Azure Key Vault token, and we can even use the Azure Key Vault REST API, something like this, with the token that we got, or that the service token provider got for us, to use a plain HTTP GET to get our password. So this is not using any .NET API anymore. It's really using the plain REST API. So if you are working with a language that is not .NET, where there is maybe no API available, feel free to use this REST API to access Key Vault. You have always access to this token through the Azure CLI command that I showed you before. And if we run this guy, let me quickly show that, we get a 200. And if I scroll down and I zoom in a little bit, you will see that the REST API also works perfectly fine. And this is essentially what's happening behind the scenes. Behind the scenes, our Azure Service Token Provider uses this REST API to get an access token to Key Vault, and then the Key Vault client will use this access token to talk to Key Vault on our behalf. Okay, so this was the story for debugging this stuff locally. How does it look like in Azure? Well, let's take this guy here and publish it. I know that we do not right-click publish in reality, of course. However, for demo purposes, I will do it. So I will select the new web app that we created together a few minutes ago. Come on, here we are. This is the live version of my demo. Yes, it should be deployed in only a few seconds. So let's quickly recap what we had to do. Well, it's really quickly. Nothing, because there are no secrets. When we debugged it locally, it used my Microsoft account, and now in the cloud, the Azure Service Token Provider will, well, what will it do? It doesn't have Azure CLI. It doesn't have Visual Studio. Where does it get the information from? The answer is environment variables. So app services automatically sets to environment variables, and you will see them if I fix the URL here. You will see them in a second. You should see them in a second. It's called secrets. Did I do something wrong? Okay, you don't see them. I have no idea why. Interesting. Let's quickly... We could do some debugging, but I don't want to do debugging. I've tried that multiple times before I went on stage, but maybe, yep, something is broken. Oh, I see. Generally, maybe we had another issue here. Oh, it's not a problem. We had another problem during publishing this stuff. It was also not successful creating my virtual machine. Thankfully, I planned for that. It's always an issue with some Wi-Fi's here on these conferences. I did exactly the same deployment before I went on stage, and hopefully this guy still works. Yes, it does. So this is exactly the same thing that I showed you in my demo, but this I just pre-provisioned that before I went on stage. And what you see here, and that's the interesting thing, Azure provides in an app service plan, it provides a local address. Do you see the local address? Vira 127.0.0.1. It provides a web API with a secret, and these two values come from an environment variable. Let me quickly show you the code. You see it here. It comes from two environment variables which are set in app services, and this is what's happening behind the scenes. It uses this API, this REST API, and the secret here, together with the client ID, to fetch the token that then can be used for Key Vault to get the credentials out there. And with that, we have our password again. Here it is, our password, this time running in Azure without me having to provide anything. And the whole key rollover and things like that is done by Azure. I do not have to maintain the secret, it's done automatically. Never give this secret away. The thing that I do here, so returning the content of this of these environment bus, is not a good idea security-wise. You shouldn't do that. It's just for demo purposes. However, even if somebody gets it, this thing is only available via localhost on the app service. So if you want to use this MSI secret to get an access token, for instance, you would have to be able to run code on the server locally. So it is more than one level of security that we are dealing here with. Of course, I could take this access token and try it, but you have seen that before. This was a nice demo for web apps, but of course, a lot of you are probably not only using app services, but you will maybe also use some virtual machines to run your applications with Windows or Linux. And in the final 10 minutes that we have, I would like to show you how these things look like if we provide them in virtual machines. Let's quickly take a look at this script here. This script is nothing really special. If we take a look at the first upper part here, it just creates a VNet, it creates a public IP address, it creates a NIC, and it creates a VM. In that case, it is an Ubuntu virtual machine, just a Linux VM. Of course, you could do exactly the same demo with a Windows server. It works exactly like that. The important one is that line. This line, AZVM identity assign, is the same as the web identity assign that we had before, but this time it's specifically for virtual machines. What does it do? It again provides a well-known IP address that is only accessible from within the virtual machine, that any application running on this virtual machine can use to get access tokens for Key Vault. This is what it does here. Previously, it installed a VM extension, a small component of code on your VM that you had to talk to. But this is obsolete. Do not use that anymore. Now, the new version, which is live already, it is again based on a REST API that is used behind the scenes. So, the second thing that you see here is again our AZ Key Vault set policy. But in that case, I'm not assigning permissions to my service principal of the web app, but this time I'm assigning it to my virtual machine. So if we take a look at the Key Vault, after I execute this guy, if I take a look at the access policies, we will see that we now have three items. We have my user, this is used during development. We have our web application, this is app service, and this here, the Techorama MSI demo, is again an application, but this is the virtual machine account. So you can see you can have one Key Vault and multiple applications accessing this Key Vault. You might ask yourself at that point in time, well, do I really need a separate service principal for every single web app, for every single virtual machine? Wouldn't it be nice to have one explicitly created managed service identity that is used, for instance, by multiple microservices? Answer, you are lucky. It's already there, but it is in preview. So you can now, today, already in preview, create a managed service identity as a separate asset in your Azure subscription and then assign an existing managed service identity to web apps and VMs. So with that, you can reduce the number of service identities that you have, and you can reuse them across multiple, for instance, microservices. I will not go into demo that, but I'm sure you will find it out. So finally, we can connect to this machine. Let's do an SSH, and I'm going to connect via that guy, and let me quickly look up the virtual machine. Here is the virtual machine, and copy the DNS name. Here is the DNS name, and put it here, and sign in. Nice. Now we are connected to this virtual machine. This is the virtual machine, and I'm trying to access my secret from within this virtual machine. Well, first we have to install a few tools. Let's do a quick sudo apt-get update to OK, to refresh our packages. Then we are going to install sudo apt-get install curl and IQ. Sudo apt-get install, sorry, typo. Okay, good. And now we can access a well-known URL. You see it here. This IP address is only accessible from within the virtual machine, okay? And from this well-known IP address, we can retrieve a token by specifying the intended audience. So you just specify, hey, managed service identity, please give me my service principal that I can use to access Azure Key Vault. And what you will get back is an access token. And then you can use this access token in the next step to programmatically access Key Vault. Let's try this. So let's try this with curl. Exactly. Okay, here it is. Let's zoom in a little bit. This is what this IP address gave back. It gave us back an access token. This is again a JOT token that we can now use to access Key Vault. And as this is a REST API, I'm sure everybody understands that you can use that from any language that understands REST or HTTP, and essentially that's everybody. The connection between our VM, in that case, and the service principal was done by managed service identity. So the fact that this IP address 169 something is available results from our Azure identity assign statement. So the VM has now a defined service identity, and we do not know the secret. It's not necessary because we get always access tokens for the identity that we created or that was created by Azure. So let's final demo. Let's copy this access token and add the access token here, because now, of course, if everything works out nicely, I would like to see, here it is, my super secret password from the VM in a Linux VM without me having to specify any credentials or something like this. And here it is, here is our super secret password, just by accessing the REST API. And that is what I wanted to show you. I wanted to show you how easy it is to assign managed service identities to web apps and to VMs, and how you can use, on a lower level, REST APIs, or on a higher level, in .NET. Let's recap that. The Azure Service Token Provider API, how you can use these two ways to get access tokens. And you have also seen that this approach works during debugging, using my interactive login to Azure, Visual Studio, Azure CLI, and so on, and it works in the cloud. And we do not have to maintain some certificates or secrets anymore. So that was the demo. Here are some tips, final tips. What if my environment doesn't support managed service identity yet? For instance, Service Fabric, Azure Batch, and things like that. Use service principals. You can create your own service principals, and you can create service principals that use client certificates to authenticate. So create service principals with client certificates, and do not save these certificates somewhere on disk. But for instance, use the import certificate thing from Windows and use the thumbprint to retrieve these certificates during runtime in your .NET application. Yeah, I managed that already. The user-assigned identities is the new stuff. It's currently in preview, and you can create service identities manually and assign them, and therefore you have less service identities inside of your Azure Active Directory. Finally, let's quickly summarize. I would like everybody in this room to stop creating config files or putting secrets into code. That should never be done. Even if you say, I often hear that argument very frequently, we do not publish our sources on GitHub, the sources are just in my local TFS, something like this, so it's no problem to check in secrets. Yes, it is a problem. In larger organizations, you cannot tell who is your friend and who isn't. Maybe somebody has access to the source control management system that shouldn't have access to these secrets. So stop adding secrets to configuration files. Use Key Vault to store all your secrets, encryption keys, certificates. It's a secure location, it is hardware protected if you want, and it's very cost efficient. During development, do not store some credentials in local config files again, but use your Azure Active Directory account, either your Azure AD account or your Microsoft account. Ideally, use multi-factor authentication. Present your thumbprint on your phone. You do not have to remember a password anymore nowadays, and then you are authenticated on your developer workstation, and the whole application, the whole debugging process will just work, and you do not have to care about the secrets anymore. And finally, if your target environment is already supported for managed service identities, try managed service identities. I hope the demos in the last 60 minutes showed you that using this stuff is really simple. It is a one-liner in .NET, and it's only a few curl statements. If you want to do it in other programming languages or in the command line in Bash, for instance, it's really simple to use and it's very powerful. With that, we are out of time. Time flies. Thank you for coming. I hope you have a great Techorama. For me, it's the last session for this year. I have to catch my flight home to Austria. I really enjoyed coming to Belgium again, and I hope I will be part of the next Techorama next year too. So thank you very much for coming. Enjoy the rest of the conference.